This is a simple iron rod. If you wrap a few turns of wire around it and pass electricity through, it becomes magnetic, turning into an electromagnet. And if you reverse the current, the magnetic field flips as well. Just like that, you now have something that can generate and change its magnetic field at will. Just like a permanent magnet, like poles repel, and opposite poles attract. Now let's reshape it a bit. You mount it on a shaft so it can spin. This becomes the rotor. Then on both sides you place curved permanent magnets, forming the stator once you connect the power. The rotor becomes magnetic, and because like poles repel, it starts to rotate. But here's the problem. Once it reaches a horizontal position, opposite poles attract and it gets stuck. So if you want it to keep spinning, you need to constantly reverse the current in the coil, flipping the magnetic poles again and again but manually switching wires non-stop. That's just not practical. So cleverly, you install two curved copper segments at the ends of the rotor coil. This is called a commutator. Then you press two carbon brushes against it with springs, connecting them to the positive and negative terminals. Now watch closely. When you power it on, current flows through the brushes, into the commutator, into the coil, and back out, giving the rotor its magnetic field. It gets pushed by the magnets and starts spinning. As it passes the horizontal position, inertia keeps it moving. And at that exact moment, the brushes slide onto the next copper segment, automatically reversing the current. The magnetic poles flip, and the rotation continues smoothly. Just like that, continuous motion is achieved. But then you notice another problem. When the power is turned off, the rotor often stops in a position where it's held by magnetic attraction, and the brushes sit right between segments. Meaning next time it won't start, so you improve the design, turning the rotor and commutator into 3 segments instead of 2. Now when powered, different sections create alternating magnetic poles. One gets repelled, another gets attracted, and together they keep the rotor moving in a steady direction. With the commutator constantly switching current, the magnetic field keeps flipping and the motor keeps spinning. Congratulations, you've invented a DC motor, a simple yet powerful machine that converts electricity into motion.